If you walk from a dark room out into the bright sunlight, your pupils will immediately constrict. You don't have to think about it, and you certainly never had to be taught how to do it. It is a biological baseline, an involuntary physical reflex hardwired into your nervous system. In behavioral science, we call this an unconditioned response. It is an action triggered automatically by an unconditioned stimulus. If you place a bowl of food in front of a hungry dog, the dog will salivate. The food is the stimulus. The saliva is the response. No learning is required. Curious, in 1902, the Russian physiologist Ivan Pavlov was studying these exact digestive reflexes in canines. He was mapping the precise mechanics of how food triggers salivation. But during his lab work, he noticed a strange anomaly. The dogs in his care began drooling before the food was even presented. They would start salivating at the mere sight of his lab assistant walking into the room, long before eating. Dogs are not born with a biological reflex to drool at human beings. They had acquired a brand new behavior. The question was, how exactly does an animal's brain take an involuntary, hardwired reflex and unconsciously attach it to a completely random trigger in its environment? To figure out how this associative glitch happens, Pavlov built a controlled experimental setup. He isolated his subjects and used a measuring device to precisely track their salivary output in response to highly specific, isolated stimuli. This equation breaks down his findings. Step 1, present the unconditioned stimulus, food, and measure the response, saliva. Step 2 introduces a neutral object. Pavlov rings a bell, producing 0 response. Step 3, the pairing phase. The bell, followed immediately by food, triggers the saliva response. For this connection to form, the two stimuli must occur almost simultaneously. Pavlov called this a law of temporal contiguity. If the time gap is too large, the brain fails to link them. After repeating the pairing, we reach step 4. The food is removed, the bell is rung alone. The dog salivates. The neutral bell becomes a conditioned stimulus, triggering a conditioned response. This sequence is known as signal learning. It proved that learning is not limited to conscious studying or practicing. It is a measurable, mechanical hack of our underlying biological hardware. Because this process operates like a strict formula, the strength of conditioned behavior can be dialed up or down by adjusting the variables, particularly the timing. This timeline compares sequencing strategies. Delay conditioning, ringing the bell slightly before food arrives, creates the strongest connection. Conversely, backward conditioning yields poor results. Once associated, the brain casts a wide net. Through generalization, the organism might salivate at entirely new, similar triggers. But what happens if you keep ringing the bell day after day and never provide food again? Without the unconditioned stimulus continuously reinforcing the pairing, the learned behavior gradually fades out. In behavioral science, this severing of the connection is called extinction. However, an extinguished behavior is rarely erased completely. Organisms frequently exhibit spontaneous recovery, a strange phenomenon where an extinguished conditioned response suddenly reoccurs out of nowhere, long after it seemed to have been forgotten. These variables reveal that our unconscious associations are not permanent fixtures. They are highly fluid links that form, generalize, fade, and resurrect, based strictly on the feedback we receive from our environment. While Pavlov focused heavily on animal digestion, this exact same classical conditioning process governs our own involuntary emotional reactions. Consider a student who takes a difficult exam and fails entirely. The overwhelming feelings of panic, shame, or anxiety they experience in that moment serve as a biological, unconditioned response to a highly stressful event. But just like the bell paired with the food, the physical environment surrounding the student, the specific classroom, the desk, or even the teacher, is paired with that intense emotional pain. The room itself becomes a conditioned stimulus. If educators and students don't realize this associative link of the RAID, the student will step into that classroom the next day, and their physical body will automatically trigger an involuntary fear response, regardless of whether there is a test. Because we know the mechanical rules that build these responses, we also know exactly how to break them. In psychology, this is done using desensitization techniques. The strategy is to intentionally expose the student to a very weak, unthreatening form of the conditioned stimulus, perhaps just visiting the classroom for a brief, relaxed moment. Gradually, the strength and duration of that exposure are increased, always ensuring the negative consequence of failing a test never occurs. By systematically forcing the environment into the extinction phase, the brain eventually severs the traumatic link. Understanding the exact anatomy of how an association forms gives us the precise tools required to dismantle our own habits of fear.